In the first part of this two-part episode, we discussed early indications as to how NASA's future plans seem to suggest that this antiquated behemoth may be on its way out. And for the sake of our future in the solar system, let's hope so, because the SLS is such an outdated and expensive waste of money, over $20 billion thus far, plus $1 to $2 billion per launch, that I can't see how this rocket is going to be able to allow us to pursue our ambitions throughout the solar system in the future. And as we saw in the first episode, it wasn't just my opinion that seems to suggest this. There's a lot of things that have been happening with NASA recently that suggest that the SLS is rapidly falling out of favor. NASA's evolving plans with the Lunar Gateway, I think, are the strongest indication of this. Instead of building the gateway using the SLS, NASA has opted to use private rockets, namely the Falcon Heavy with SpaceX, most probably. In addition, they are going to be resupplying the gateway, also with the Falcon Heavy. As a matter of fact, the gateway seems to be specifically designed for commercial rockets rather than the SLS because of its curious orbit. But it's NASA's long-term plans for the exploration of the solar system after Artemis, which were released only a couple of weeks ago, that I think are the strongest indicator for the death knell of SLS and the possible use of the Starship instead. So buckle in and get ready, because we're about to embark on a very exciting and unconventional episode of The Angry Astronaut. Good evening, and welcome to another episode of The Angry Astronaut, part 2 of a two-part series. So if you are watching this and have not yet watched part 1 of the phase out SLS, phase in Starship, or something along those lines kind of title, then go back to the immediately previous video and watch that one first. Otherwise, this one might not make a whole lot of sense. All right, where we left off before, first of all, I've added yet another prop. This is the old Lego concept of the Lunar Gateway, since I talked about it so much. This is, I guess, what passes for the logistics module. You see the hatch opening up and then deet, deet. Yes, I'm a child at heart. I love this stuff. But in any event, I've always loved this set, well, just because I'm a big fan of the Lunar Gateway. But in any event, I have it included for this particular episode, along with the props that I just added. I hope you guys like them. So, all that having been said, so we covered everything that NASA's planning now, all of the indications that NASA may be moving away from the SLS and more towards conventional, as to say, commercial rockets. Not to say, of course, that Boeing isn't a commercial rocket, but given all of the lobbying that they have in their favor, they may as well be a government institution at this point. So now we need to talk about the more distant in the future plans for NASA, things that they intend to do once they're completed with Artemis, or once they have Artemis well on the way, the gateway is established. Perhaps they even have a fuel depot in lunar orbit, a lunar base present, those sorts of things. Once they've accomplished all of that, their intent is to move towards Mars. Now, it's entirely possible that SpaceX will have gotten to Mars by now, but this isn't NASA's plan. So in any event, right now we're talking about NASA and the way that they would implement the Starship into their plans. But They're not planning on going to Mars after they're done with the moon. There seems to be a shift in that regard. Instead, they're going to Venus. And then, as near as we can tell, they're going to Mars after that. And from there to the Asteroid Belt. And all of this, by the way, as manned expeditions. And I'm going to explain this in detail to you right now. But before going on an interplanetary mission, NASA is looking at alternate forms of propulsion, and one of these is nuclear thermal propulsion, a concept that's been around for many decades. As a matter of fact, Wernher von Braun intended to use nuclear thermal engines in the top stage of the Saturn V to get to Mars. Now, I've described this process in the past, but here it is in a nutshell. A nuclear thermal engine superheats liquid hydrogen and then drives that element out the nozzle of the rocket at a very high rate of speed because hydrogen is the lightest element in the universe, whereas a conventional rocket drives a propellant that's created by a chemical reaction at about half the speed, therefore half the efficiency. And that's why rockets are so inefficient today compared to alternate forms of propulsion. Now, believe it or not, these rockets have already been tested many times back in the 1970s, but they used a highly enriched form of uranium, which can be rather dangerous if you're trying to launch it into orbit. So now they're trying to use a less dangerous form of uranium in order to provide a more practical form of rocket for use in outer space. Remember in the last episode when I said a propellant depot around the moon could carry a different kind of fuel? Well, that fuel would be liquid hydrogen, which would be the primary fuel for this type of propulsion. And it would be worth it because of its efficiency. It could drive this ship to a much higher rate of speed, allowing it to reach Mars in about 3 months instead of 6. On top of providing lower transit times to Mars, nuclear power could also provide invaluable sources of energy for long-term habitation on the red planet. Since long-term dust storms can block out the sun and therefore render our solar panels useless, nuclear power is an obvious choice, at least for a backup. And if you're using low grades of uranium, there's no danger of weaponizing it. And of course, this type of propulsion could get us to Venus even quicker, as is the case with this particular vessel called the Havoc, or the High Altitude Venus Operational Concept. Now, going to Venus first makes a hell of a lot of sense. Look at the diagram on the left. A journey to Venus with a flyby and a return to Earth would take less than 1 year, as opposed to a journey to Mars, which would take 2 years minimum. Now, nuclear thermal engines would reduce the length of both missions considerably, although the Venusian mission by a lot more, which means we would gain valuable interplanetary experience with travel without having to go so far away from Earth for so long. But there are other benefits to going to Venus besides just a shorter trip. Now, 20 years ago, if I had told you that there was life on Venus, you would have locked me up with a straitjacket. But these days, it's looking like not only is life possible on Venus, but also probable. And not on the surface, of course, where there's insane pressures and insane temperatures, but in the atmosphere. Now, the upper atmosphere of Venus is very much like Earth, both in terms of temperature and in terms of pressure. It is, of course, comprised of carbon dioxide instead of oxygen, but nevertheless, if you were to tear your spacesuit in the atmosphere of Venus, it would not mean a decompressive death like other places in space. Instead, you would have plenty of time to get back to safety. In this atmosphere, we have already detected things like carbonyl sulfides, which are very difficult to produce without bacterial life, although volcanoes can do it, but there hasn't been any sign of volcanism on Venus for at least 2 million years. While I'm talking, keep looking at the Havoc, its shape, its configuration, and how it might coincide with the setup of the Starship. This, by the way, is a sample return mission from Venus, which is part of the overall Havoc mission, on top of a flyby. Back to Venus and its strange atmosphere. The strange dark streaks that we are so accustomed to seeing are made up of what's called unknown absorbers, something that apparently reflects and absorbs ultraviolet radiation, affecting the albedo or the brightness of the planet. It also affects the planet's climate, much as bacteria and microbial life does on Earth. On top of that, examinations, spectrographic examinations that is, of these unknown absorbers show that they're physically and chemically similar to various types of bacteria here on Earth, strongly suggesting that there is something alive in the Venusian atmosphere, although it's probably something radically different from anything we have here on Earth. What a discovery that would be. But have a look at the Havoc again. Does this look like the kind of ship that you would put on top of an SLS? No, it would have to be assembled in orbit piece by piece. Or, alternatively, this ship, which contains a gondola and a balloon and a variety of other things necessary in order to explore the Venusian atmosphere, could very easily be carried within the cargo bay of the Starship. In fact, it almost seems specifically designed for it. Now, this is all speculation, of course, but conceptual ideas on this particular mission are due in about a year, and I would be very surprised not to see the Starship included in the Havoc's overall journey to discover life in the Venusian atmosphere. And by the way, speaking of concepts, here's a couple more that are due in 2021 under the Revolutionary Aerospace Systems Concepts Contest, sponsored of course by NASA. Firstly, there's the Durable Low-Mass Lunar Habitat, and as you can see, this is on Mars, of course, but the intention is for this to be used at the lunar South Pole as well as on Mars. Quote, "The habitat should be capable of reuse, as it will serve as the starting point for expanding to greater crew capabilities on the surface and for preparation for Mars missions. Thus, teams should identify how their habitat can be used to support both of these goals." And by the way, it has a dry mass limit of 6,000 kilograms and an annual budget of no more than $1 billion per year. Now, how the hell are you going to deploy this thing if the SLS alone costs $1 to $2 billion a year? You're going to have to use a different form of transportation. Another concept is the Minimum Mars Ascent Vehicle, something a hell of a lot smaller than this, a dry mass limit of 5,000 kilograms and a wet mass limit of 20,000 kilograms, designed for only 2 astronauts. Now, the teams would have the option of either the vehicle carrying enough propellant to make the ascent on its own, or to manufacture additional propellant on the surface. And by the way, the vehicle might look something like this. And if that looks familiar, well, it is. It's the Crew Dragon, or rather the Red Dragon, which Elon Musk once considered for landing on the Martian surface. He abandoned the project, but something like this would be ideal for this ascent vehicle that NASA has in mind. By the way, the teams need to describe how this ship would be deployed to Mars, and the budget would be no more than $2 billion per year. So if you have this thing consuming $1 to $2 billion a year, how the hell are you going to make your project work? So if the SLS is the wrong ship for all of these proposals, how exactly does the Starship fit into all of this? Well, not the way that SpaceX or Elon Musk or perhaps the rest of us would want, but nevertheless it would play a vital part in every one of these proposals. The Starship would reach low Earth orbit with a Havoc-like vessel in its cargo bay, bound either for Venus or for Mars. And once it reached low Earth orbit, everything would go according to the usual procedure. The Super Heavy would return to Earth and pick up a cargo ship in order to refuel the Starship, except the Starship would not be heading to Mars itself. Once the Super Heavy had a tanker Starship, it would need to refuel the main Starship at least a couple of times in order for it to reach a geosynchronous transfer orbit and reach the lunar gateway and the propellant depot. At that point, it would discharge its cargo, namely the Havoc ship. The Havoc would top off its fuel tanks with liquid hydrogen for its nuclear thermal propulsion, and it would go on its way to either Mars or Venus. Not nearly as ambitious of a plan, but nevertheless a very good plan for the exploration of the solar system, at least to start off with, before you start colonizing anything. But why go through all of this when the Starship can handle it itself? Well, because I don't think that NASA is going to be comfortable with using the Starship suicide dive, as I like calling it, for human beings for quite some time. They may use it for cargo, but SpaceX is going to have to demonstrate that this can be safe and used many, many times over before I think NASA is going to be comfortable to put astronauts on board. Now, once again, SpaceX might beat NASA up to the punch and get their own people to Mars first. That's always a possibility and might change NASA's perspective on these things. Instead, it would appear that NASA wants to use smaller ships with parachutes and a combination of powered landings in order to get humans to the surface and scale up from there. But lest you think they're being too conservative, wait until you see the last proposal. That's right, your eyes aren't tricking you. NASA wants to send a manned expedition to Ceres, which is the largest by far object in the asteroid belt, and has been under observation until 2018 by a probe called Dawn, which discovered a hell of a lot of interesting things. For example, it's been estimated that Ceres has more water than the entire planet Earth beneath its surface or in ice deposits, and it is a hotbed, or at least was, of cryovolcanism. Okater is one of its most interesting features. The bright spot in the center suggests the presence of salts and also some sort of volcanic activity, and all of these things in combination usually produce microbiotic life. At least it has on Earth. If there's a place in the solar system that's likely to have life, it's Ceres, and this isn't the only interesting spot. Also, Ikapati is another fascinating crater, and by the way, I may be butchering these names, but it also contains bright reflective qualities, again suggesting the presence of cryovolcanism, salts, and the possible presence of organic life. Speaking of cryovolcanoes, Ahuna Mons is perhaps the most magnificent example of one of these throughout the solar system, standing nearly 16,000 feet high at its highest point, an amazing thing for such a small world. It is a perfect example of what happens when you have ice, salt, and mud erupting from inside a protoplanet. I could go on, but personally, I can't wait to see the proposals on this particular mission. It's definitely going to take some sort of nuclear propulsion to take us there in any kind of reasonable time. And also a journey from Mars rather than from Earth makes a whole lot more sense. It's closer, and you don't have to fight Earth's gravitational pull in order to reach the destination. Plus, since this body has so much ice and so much water, it's an endless source of rocket fuel or fuel for nuclear thermal propulsion to explore the rest of the asteroid belt. This, without question, is NASA's most ambitious project to date. and the Starship could be an important part of it, and I certainly hope that it is. There are some exciting things coming in NASA's future. So, exciting, huh? At least I think it is. The whole notion that NASA may be looking to embrace the Starship to go to a wide variety of locations across the solar system, although not in the way that Elon Musk or perhaps a lot of the rest of us would want the Starship to be used, but nevertheless in a way that NASA would be comfortable with. They've clearly shown that they're open to the idea of the Starship carrying people for part of the journey. Otherwise, they wouldn't even have accepted their lunar lander proposal. So the idea of the Starship carrying people is something they're open to. I just don't think they're open to the notion of landing people with the Starship. I think that they're nervous about that. So in any event, that's why I think they have this plan. That is to say, a separate ship to be delivered to geosynchronous transfer orbit or something along those lines by the Starship, and then that ship being powered by nuclear thermal engines, hopefully, going to Venus first, and then to Mars, and then from Mars to the asteroid belt. And of course, as I mentioned in the video, the most logical way to get to the asteroid belt is to establish a presence on Mars first. It's much, much easier to travel to the asteroid belt from Mars than it is from Earth. All of this is incredibly exciting, and the fact that they're actually putting out real proposals or request for proposals on this matter. Now, this is a long ways down the line, obviously, but if SpaceX demonstrates that the Starship is ready to go a lot faster than NASA thought was possible, and therefore they have this heavy lift capability at their disposal much earlier than they thought they did, they might be willing to move forward with a lot of these plans a lot quicker, because the expense of delivering all of this cargo or all of these expeditions to these planets comes with that initial launch. That's where so much of the expense comes from. And of course, if they somehow use the SLS to do this, it's going to be $1 to $2 billion a shot. And that is something that NASA just frankly can't afford on a sustainable basis unless somebody really increases their budget. But even so, I kind of hope they don't, because it's just wasteful. The SLS is wasteful, antiquated technology, and we need to be rid of it, plain and simple. But in any event, a lot of what I said, I've said tonight, even though the plans are clear, even though everything I've told you is definitely in the documentation, and I have links in the description to prove what I say, but in terms of using the Starship to accomplish all of this stuff, that's pure speculation on my part. So it seems to fit. But nevertheless, there's no clear statement on NASA's part that this is what they intend to do. But it is very logical that they would use the Starship for these purposes, the way the missions seem to be laid out. So let's hope that that's actually going to happen. So until we actually have some solid answers on all of this, and we are making our way to the moon, to Mars, and to the asteroid belt, the whole inner solar system, and we're doing it in a way that can be successful, I urge all of you to stay angry about space.